Hello everyone, welcome again to this video. In this video we are going to talk about random variables. So our topic of discussion for this video would be random variables. So let me first list out what we are going to study in this whole chapter, and then I will quickly show you a slight overview. Okay, so firstly we are going to learn what is a random variable. Nextly, we are going to learn what is a probability distribution. We are going to learn properties of probability distributions. We are going to learn about mean, or in other words, expectation, and finding probabilities. Using PMF, or in other words, it's also known as the probability mass function. So these are our goals for this lecture. So it's going to be a bit long one, but we are going to cover all these 4 different things because it is necessary to cover them in at once. Then we can move on to the more important things, but this here builds your foundation for probabilistic distributions and probability course, right? Okay, so let us begin. What is a random variable, right? Okay, so a random variable, as you can see from the name, it's a variable and it can assume values, as all variables do. So for example, a random variable can assume a fixed set of values from a set S. So this set is called the support of the random variable. So if x is a random variable, or we call it RV sometimes in short, if x is an RV, then x belongs to S, where S is our support, or the set from which the random variable actually claims the values, right? You will understand more about it right now with the example that I'm going to give you. Suppose you toss a coin, obviously a fair one, 2 times. Let x count the number of heads. Then you have the values of x. If it counts the number of heads and you have tossed a fair coin 2 times, is basically you can either have no heads, which means you have 0 heads, you can have 1 head, or you can have basically 2 heads, right? So this is the number of heads you can have, so like 0, 1 or 2. Now we want to obviously see that this is a random variable which can take these values. So our set S here is basically 0, 1 and 2, and we can say that x is an element of S, right? Now since we know about this random variable thing now, or we just have a fair idea of what it is, a probability distribution can be constructed probability distribution is a function which gives probabilities or which assigns numbers, probabilities are simply numbers, to the random variable. So it assigns a probability for each value the random variable takes. So that means that here the value random variable takes 3 values, right? So the probability that x is equals to 0 will have a certain probability p1, right? The probability that x equals to 1 will have a certain probability p2, and the probability that x equals to 2 will have a certain probability p3. And something important which you should note here, it's the most important property or the most basic important property. Sum of all probabilities of a random variable is always 1. Always 1, right? So what it means is you can add all these values. So you can basically add p of x equals to 0 plus p of x equals to 1 plus p of x equals to 2, and you should always get 1. We are adding 3 values because here the random variable only has 3 entries. If it like had infinitely many entries, we would add all of them. We would have an infinite series. If it has finitely many, we'd add all of them. So it doesn't matter how many entries the random variables can take, because the probability distribution will assign probability to each of them, and the sum of all those probabilities would be equal to 1. Okay, so here it would mean that p1 plus p2 plus p3 should be equal to 1. Okay, so like this shapes the initial problem for us. Now the thing that is left to do, or which we are going to learn, is how to assign these probabilities, because we know that there are probabilities assigned to certain values of the random variable, like all of the values, but we do not know what are those probabilities. We do know that they add to 1, and we also do know that the probabilities are always non-negative, that is greater than equal to 0, which we can already write here, that 0 less than equals to pi is less than equals to 1. This is always the case, but we do not know what probabilities are there, right? So we can assign them like that. So for the given example, consider the sample space. Consider the sample space, which is the result of tossing the coin 2 times. It's basically HH. It can be 2 heads, 1 heads and 1 tails. 1 tails and 1 heads. Remember, the ordering is important because we do not know, because like coming a heads in the first toss and having a tails in the first toss is a completely different thing. So we might also have 2 tails, right? So this is our sample space, and we can say it's a finite space, so mod of s equals to 4. So there are 4 entries. Now consider the event x equals to 0. The x equals to 0 event, it corresponds to the fact that there are no heads, so only TT is the only entry here, right? Similarly, consider x equals to 1. This means 1 head should be there, which means HT and TH. And similarly, consider x equals to 2, which means we must have HH, right? Now, as you can see, we can assign probabilities to it. Now, as using the definition for classical probability, it's only one element from this set of 4, which corresponds to x equals to 0. This would give us 1 by 4. Probability of x equals to 1 should give us 2 by 4, and probability of x equals to 2 should give us 1 by 4. So like this sums up the probability distributions, and as you can see, 1 by 4 plus 2 by 4 plus 1 by 4 is equal to 1, which also satisfies the important property that we have stated above, right? So this is how you go about a probability distribution, right? Now we have already learnt about this probability distribution and the properties, the basic properties of it, obviously. But we would like to really formalize things and try to get on with a topic where we can actually understand what is going on, right? So let us say given that x is a random variable which follows the following distribution. So the distribution would be something like this. Let's say it takes values from 0, 1, 2, 3 and 4, and the values of x corresponding to them are, let's say, k, k by 1, k by 2, k by 3, k by 2, where k is unknown. Okay, so this is the distribution that it follows. For different values of x, it has different probabilities, where obviously we do not know. K is just a real number for all we know. You need to find k, so we need to find k. So given such a problem, you always need to remember that sum of all probabilities must always be equal to 1. So here we must have k plus k plus k by 2 plus k by 3 plus k by 2 equals to 1. So this would give us 2k plus k plus k by 3 equals to 1, or in other words it will give us 3k plus k by 3 equals to 1. Doing the LCM, you find 10k plus by 3 equals to 1, or you get the final answer as, therefore final answer is k equals to 3 by 10, right? Now this is how you find the probabilities, and now you have the complete list of probabilities. If you if you can denote probability of x equals to k as small p subscript k, then the whole distribution is now known, since the value of k is already there, which is p0 is 3 by 10, p1 is 3 by 10, p2 is 3 by 20, p3 is 1 by 10, and p4 is 3 by 20. This completes your probability distribution, right? Now after this is completed, we would try to find and define a new term which is called expectation. Expectation, or in other words, mean. So we try to know what is an expectation of a random variable or what is the mean of a random variable. Now the mean of a random variable is the average value it takes. Is the average value it takes. It is defined as firstly it is written as e. In a third bracket you write the random variable for which you are calculating the mean or the expectation, in this case capital X, and you define this as the summation, where you go over the whole sample space. So take an element y and you go over the whole sample space S, where from which x is coming, from which x is taking all the values, and you multiply y into probability that x is equals to small y. So basically you take all the values, all the probabilities, and you add them, but you just do not add them. Take each probability, multiply with it the value of the random variable which gives you the probability, and add all of them up. For an example, let us take the coin tossing example where we had probability of x equals to 0 as 1 by 4, probability of x equals to 1 as 2 by 4, and probability of x equals to 2 as 1 by 4, right? So this was the given probability distribution for tossing a coin 2 times simultaneously. The mean of the distribution distribution is given as E of x is equals to, so as I said, you need to take each of the probabilities and multiply it with the value the random variable is taken. So 0 is the value the random variable is taken, multiplied by 1 by 4, 1 multiplied by 2 by 4, 2 multiplied by 1 by 4. So it gives you 0 plus 1 by 2 plus 1 by 2, which is basically 1. So the average value of the distribution is 1, which is right here. As you can see, it's perfectly balanced, right? It's 1 by 4 on both sides and a 2 by 4 in the middle. So this middle one is the average value. So this actually is the way to find your mean of the distribution always. In general, for continuous random variables, which we shall learn later, and how to, those are the topics that would require a lot of calculus actually. So continuous random variables, we have E of x equals to minus infinity to plus infinity x fx dx, where obviously fx is the PDF or the probability density function in case of continuous random variables. So we shall learn all of this later, and how to do integration. Is it actually a separate course completely? It's on one of the most important courses in mathematics. You need to know how to integrate to do anything actually. So this would complete your expectation for the discrete case right now, but in the future lessons we would also know about how to calculate all the different properties of certain distributions, like the binomial distribution, the Poisson distribution and stuff. But for now we shall also define one more term, which we shall, or two more terms actually, which we shall need, which is variance and standard deviation. So these are the two terms that we are also going to learn because they will be helpful. Okay, so variance and standard deviation. Now variance is the spread of the random variable. Variance is the amount of spread from the mean, right? So it basically means the amount of spread it is from the mean. So the more the distribution is skewed, or more the distribution is varying, the more the variance, and the more symmetric it is, the lesser variance it has. So I'll just define it and give you the formulas, and not really give a lot of examples here, because we will be doing a ton of them in when we will be covering our distributions. Like there are like 10 of them probably in discrete case alone, and then for continuous we have like a lot of them, so we'll be needing a lot of references back then, but not now. So let us define the variance and give you the formula. The variance is defined as var of x, and you write it as expectation of x square minus expectation of x whole square. So this is the variance, and I will also define the standard deviation of x, SD of x, as just the square root of variance. Okay, and remember that SD of x is greater than or equal to 0. Similarly here. So these are all non-negative quantities. Okay. Now variance is the amount of spread from the mean, and this has been done. So I will just have to define what is e of x square, because e of x, you know, is just the sum over all the sample space where you multiply y, and you multiply y by the probability of y for all such y's in the event space. Similarly, in when you are calculating e of x square, you just multiply the same thing, but you multiply y squared multiplied by probability of x equals to small y, right? And this gives you the variance of the function, because e of x square minus e of x whole square will give you the variance. So in simple words, therefore variance of x should be equal to y belongs to s y square into probability of x equals to y minus y belongs to s y into probability of x equals to y, but this has been whole squared. This is the variance. Okay, if you get a whole root over it, it will become the standard deviation. So this would complete our video for this session, and in the next sessions we would start doing the discrete probability distributions such as binomial distributions, Poisson distribution, geometric distribution, and so on and so forth. Anyways, so I'll see you in the next video, and meanwhile please do check the description for the Better Maths app. It's a statistical math app where you can have all the calculators, and the notes for whatever the videos we are doing is also provided in that same app, as well as the video solutions. Do check it out. Thank you.